On the Pacific coast of South America, northern Chile holds one of the strangest landscapes on Earth, the Atacama Desert. It stretches for about 1,000 miles along the coast, yet its defining feature is not the ocean beside it. It is the almost total absence of rain. This is not a desert created simply by heat or distance from water. The Atacama sits beside the Pacific, near mountains, coastlines, salt flats, volcanic terrain, and high plateaus. But its geography works like a natural machine designed to remove moisture from the sky. The result is the driest non-polar desert in the world, a place where some weather stations have never recorded rainfall and where dryness has shaped geology, history, science, and life itself. The scale of the Atacama is enormous. It covers around 105,000 square kilometers, and if the barren lower slopes of the Andes are included, that figure rises to about 128,000 square kilometers. It is not just a patch of sand, but a long desert plateau running between the Pacific Ocean and the Andes. Its northern edge reaches toward Peru, while its southern transition approaches the Chilean littoral region. To the east, the landscape becomes linked with the drier highland ecosystems of the central Andean dry puna. This position matters because the Atacama is shaped by borders of climate as much as borders on a map. It is squeezed between ocean, mountain, high pressure, and cold current. The Atacama's dryness begins with a double rain shadow. On one side stand the Andes, high enough to block moisture coming from the Atlantic side of South America. Air that might otherwise travel westward loses its moisture before it can cross those mountains. On the other side, the Chilean coast range creates another barrier near the Pacific. Many deserts are dry because one major source of moisture is blocked. The Atacama is unusual because it is trapped between two barriers. Moisture from the east is stopped by the Andes, and moisture from the west is limited before it can penetrate far inland. The desert is not merely located in a dry region. It is physically protected from rain by the land around it. The Pacific Ocean adds another layer to the puzzle. Along the Chilean coast runs the Humboldt Current, a cold, north-flowing current that cools the air above the sea. Cold air holds less moisture than warm air, but more importantly, it stabilizes the atmosphere. Stable air does not easily rise, and rising air is usually needed to form rain clouds. This means the coast can produce fog without producing much rain. Moisture may appear as low cloud or mist, but it often cannot climb, condense, and fall as precipitation. That is why the Atacama is also the largest fog desert on Earth. Fog can matter locally, but it cannot overcome the larger system keeping the interior dry. The South Pacific anticyclone makes the desert even drier. An anticyclone is a high-pressure system, and high pressure usually means air is sinking. As air sinks, it warms and becomes less likely to form clouds. In the Atacama, this high-pressure pattern suppresses storm development over a region already starved of moisture. The mountains block wet air, the cold ocean current stabilizes the coast, and the anticyclone pushes the atmosphere toward clear, dry conditions. This combination is why the Atacama's aridity is so persistent. It is not a temporary drought waiting for the next wet cycle. It is a long-term climate structure, reinforced by several independent forces working together. The numbers are difficult to imagine. Average annual rainfall in parts of the Atacama is around 15 millimeters, less than many cities receive in a single brief storm. Some stations have never recorded rain at all. Evidence suggests that certain areas may have received no significant rainfall for centuries, possibly from 1570 to 1971. The desert's hyperarid conditions are not recent either. They date back at least to the Miocene, meaning parts of this landscape have been extremely dry for millions of years. That kind of time scale changes what a desert can become. Soil develops differently. Erosion slows. Organic decay is limited. The land becomes an archive of dryness. Life in the Atacama is not absent everywhere, but it is pushed to extremes. In the driest zones, the soil can contain so little microbial life that scientists treat it as one of Earth's closest analogues to Mars. This does not mean the Atacama is identical to Mars. It is still part of Earth, with an atmosphere, gravity, and biological history. But its dry, chemically harsh, low biomass soils are useful for testing instruments that may one day search for life on another planet. If a tool cannot detect faint biological traces in the Atacama, scientists must ask whether it could perform well on Mars. The desert becomes a proving ground for the search for life beyond Earth. The same dryness that makes the Atacama difficult for life makes it extraordinary for astronomy. Water vapor in the atmosphere interferes with many kinds of observations, especially at infrared and millimeter wavelengths. The Atacama's high altitude, dry air, and dark skies reduce that interference. Large areas also have very little light pollution, giving telescopes access to a clearer view of the universe. This is why major observatories operate there, including the Atacama Large Millimeter Array, known as ALMA, and the Very Large Telescope. In most places, clouds and moisture hide the sky. In the Atacama, the missing rain becomes an advantage, turning the desert into one of Earth's great windows into space. Human history in the Atacama is much older than its modern scientific reputation. People have lived in and around the region since at least 7000 BCE, when the Chinchorro culture settled along the coast. Coastal life offered resources that the interior could not easily provide, especially from the sea. Later communities, including the Atacamino and Aymara, adapted to oases, highland routes, and the wider Andean world. Their survival depended on detailed knowledge of water, trade, movement, and terrain. The desert may look empty from a distance, but for people who understood it, it contained paths, resources, and places of settlement. The Atacama was never just a blank space. Under Spanish colonial rule, the desert became tied to ports and mineral movement. Coastal towns developed as links in export networks, especially for silver. But the most dramatic economic transformation came in the 19th century, when sodium nitrate deposits became valuable. Nitrates were crucial for fertilizer and explosives, which made them strategically important in a rapidly industrializing world. The Atacama's dryness helped preserve these deposits, and global demand turned the desert into a prize. This is one of the great ironies of the region. The same lack of rain that made farming difficult helped protect mineral wealth underground. A landscape that seemed hostile to settlement became intensely valuable to states, companies, and workers. The struggle over nitrate-rich territory helped ignite the War of the Pacific, fought from 1879 to 1884 between Chile, Bolivia, and Peru. The war reshaped the map of the region. Chile expanded northward, Peru lost territory, and Bolivia lost its access to the coast. For Bolivia, that loss remains one of the most consequential national wounds in its modern history. For Chile, the Atacama became central to economic expansion. This history shows that deserts are not politically empty just because they are sparsely populated. Resources can make dry lands intensely contested. In the Atacama, climate, minerals, borders, and national ambition became inseparable. Today, the Atacama remains sparsely populated, but it is economically and scientifically important. Copper mining is one of the region's major industries, connecting the desert to global technology, construction, energy systems, and trade. Tourism has also grown, built around salt flats, volcanoes, geysers, stargazing, and landscapes that feel almost extraterrestrial. Visitors come for silence and emptiness. But those qualities are partly the product of powerful environmental forces. At the same time, astronomers and planetary scientists continue using the desert as a natural laboratory. The Atacama is not valuable despite its harshness. In many ways, it is valuable because of it. Its extremes make it useful, memorable, and rare. The Atacama Desert is a reminder that absence can shape a place as strongly as presence. The missing rain preserves minerals, limits life, exposes geology, clears the sky, and creates conditions that resemble another planet. The missing clouds help telescopes read deep space. The missing biological abundance helps scientists test how to search for life where life is difficult to find. And the missing easy water shaped thousands of years of human adaptation and conflict. The Atacama is not just the driest nonpolar desert on Earth. It is a landscape where geography, climate, science, and history all meet around one central fact: rain did not simply become rare here. It almost disappeared. If you found this helpful, please like this video and subscribe for more explainers.